for lesson 3.6, adding and subtracting rational numbers with unlike denominators. So in this video, we are going to be adding and subtracting fractions that don't have the same denominators. Also, they are going to be positive and negative. So first, we need to remember the rules for adding and subtracting positive and negative numbers. So remember, same signs we add, different signs we subtract. So for example, -4 plus -5, those both are negative numbers. We have same signs, so we add them and we keep the sign, -9. If they are different signs, then you would have either -4 plus 5, or we could have +4 plus -5. In both of these cases, the signs are different. One is positive, one is negative. We subtract to find the difference, and in both of these cases, the difference is 1. However, in the first example, my answer is +1 since there are more positives than negative. 5 is bigger than 4. And in the second example, my answer is -1 because the 5 is negative and 5 is bigger than 4. We also talked about changing subtraction to addition and using the keep, change, flip idea like we use with dividing fractions to change a subtraction problem into addition so that we can just use these same two rules. So for example, if you had -4 minus 5, you would change that to -4 plus a -5, which follows our first example and would be -9. You might have -4 minus a -5, which changes to -4 plus 5, which follows our second example. And finally, you might have +4 minus 5, which changes to 4 plus a -5, which follows our third example. And you could also have 4 minus a -5, which becomes 4 plus 5, which is 9. So be very careful as you're working with fractions, because not only do we need to remember how to work with fractions for addition and subtraction, but we also need to remember these rules as well. Let's do a quick visual of adding fractions. If we take this rectangle and we take 1/3 of it and add 1/2 of it, we're trying to figure out what portion of that rectangle is now shaded. It's very hard to do that since all the pieces are different sizes. So we need to make sure that we break this rectangle up into equal pieces, and that is done by finding a common multiple of those denominators, 3 and 2. In this case, I can split this into 6 nice even parts, and you can see that my original 1/3 is now showing as 2 of the 6 parts, and my original 1/2 is now showing as 3 of the 6 parts, which is a total of 5 of the 6 parts. So this is a nice visual of why we need to have our pieces broken into the same sizes so that we can accurately add and combine them. So quick reminder, step 1, notice this is the same as in the previous two. Convert mixed numbers to improper fractions. Step 2, find a common denominator. Step 3, add or subtract the numerators only. Remember, the denominators stay the same. And then, of course, step 4 is to simplify. So let's get started. The first example, this is on your notes. We have -1 3/8 plus 5/6. So just before we even start, we have a negative and a positive. These are different signs, so we're going to actually be subtracting once we are all ready and have common denominators. But first thing we need to do is convert this mixed number. So -1 3/8 is -11/8 plus 5/6. Now we need to find a common denominator. The least common multiple between 8 and 6 is 24. So to convert these so that they have a common denominator, I'm going to multiply both the numerators and the denominators so that the fractions have the same value, they just have a different denominator. So times 3 to make 8 into 24, and times 4 to make a 6 into 24. So now I have negative 33 24ths plus 20 24ths. So as difficult and frustrating as fractions are to work with normally, now we have an even more difficult task because we have a negative fraction and a positive fraction. So as I mentioned before, these are different signs, so we're actually going to be subtracting. The the denominator is 24. That does not change. The numerator is what we're looking at. So all really we need to solve is this problem right here, negative 33 plus 20. So once you find the common denominator, write it down, forget about it, and just look at the numerators as if you were solving a problem with integers. So negative 33 plus 20, those are different signs, so we're going to subtract 33 minus 20, that's 13. Since 33 is the bigger number and it's negative, my answer is negative 13 24ths. And since those cannot be simplified at all, that is my answer. Okay, let's try another example. Step 1 again is to convert our mixed number to an improper fraction. So 2 times 8 is 16. 16 plus 6 is 22 over 8. Now again, before we go any farther to find a common denominator, let's just see we have negative. We actually have a subtraction problem. So once I make my common denominator, I'm going to change this, keep, change, flip to an addition problem, but be careful that you don't keep, change, flip, don't use the keep, change, flip that we use with division. You want to do keep the first, change subtraction to addition, and change the second fraction to its opposite. But first let's do our common denominator, which in this case we can just leave this one as 8. So we end up with negative 6/8 minus 22/8. Okay, so here's what I was saying. We want to change this to negative 6/8 plus negative 22/8. Now we can use our same signs, add and keep the sign rule. So our denominator stays 8. Negative 6 plus negative 22 is really all we're looking at here. So now we know the denominator is going to be 8. We can almost just set it down over here and work on the numerators. We're going to add 6 and 22, which is 28. And since they're both negative, it stays negative. Now this can be divided, simplified, both the numerator and denominator by 4. So we end up with negative 7 over 2, which is also the same thing as negative 3 1/2. That was a lot for one problem. So again, you can see you really need to take your time with these. If you're rushing, there's so many opportunities to make mistakes. So let's try a few on our own. Okay, for this first one, we have 2/7 minus 3 1/2, which is 7 over 2. Find a common denominator is going to be 14. So that becomes 4/14 minus 49/14. We are doing 4 minus 49, so the bottom is 14. 4 minus 49 is negative 45. So that is our fraction or our numerator for our fraction is negative 45. If you want to convert this to a mixed number, You can. 14 goes into 45 3 times without going over. 3 times 14 is 42, so that leaves 3 out of 14 left. Okay, jumping over here to this one, we have negative 13/5 plus 2/3. These are different signs, so we're going to end up subtracting. To find a common denominator first, we use 15. So we end up with negative 39/15 plus 10/15. Again, we know the denominator is going to be 15, so we really just need to focus on those numerators. Negative 39 plus 10 is negative 29. You can leave it like that, or you can convert it to a mixed number, which is negative 2 and 14/15. All right, and for our last one, this one I'm going to do this first double negative, just so we don't even have to think about it again, becomes a plus. So 2/3 plus 4/9 is really all we're working with here. Make that one a little bit easier. Change the denominator to 9, so we have 6/9 plus 4/9 equals 10/9, or 1 1/9. All right, just for a little bit of extra practice with word problems, looking at some differences between adding and subtracting in word problems so we can help identify which is which. In the first example, while making desserts for a bake sale, Luke used 1/2 of a scoop of brown sugar as well as 1/10 of a scoop of white sugar. How much more brown sugar did Luke use? This one is the key word, how much more. So that is going to tell us that we subtract the two numbers. In the second example, 3/10 of the trumpet section of the students in the band are in the trumpet section. 1/10 of the students in the band are in the trombone section. What fraction of the students in the band are in the trumpet section or the trombone section combined? Here the key word is combined, which means to add. So just look out for those key words so you know with a word problem which operation to solve. One other example, Mrs. Palmer wants to make banana bread, but she realized she didn't have any flour. After borrowing some from her neighbor, she had 1 3/4 cups left over. How much flour did she borrow from her neighbor? This one is a little bit tricky. Would it be add or subtract? If she needs 3 1/2 cups and she has 1 3/4 left over, that means she borrowed more than she needs. So to get that, we would need to add. So the key there is that she has it left over. She used the 3 1/2. She had 1 3/4 left over, so she borrowed the 1 3/4 plus 3 1/2.